Hi, welcome back to the Novo Larder. In this video, I would like to discuss about pulse electrical field application during the priming process. Pulse electrical field application can be considered as emerging technology, which is often used in plant-based food manufacturing, especially when the plant-based food materials are used in food processing. For example, when they are used in frying, drink, or jam, or used to incorporate in any kind of food manufacturing. So in this video, I hope to discuss about what is the pulse electrical field application and benefit of that during the frying process. Pulse electrical field is short but repetitive electric pulse with high voltage. Short means it is only about 4 microseconds or milliseconds but applied continuously. The food material is placed in between two conducting electrodes and lead into the electroporations of cells. As the above figure represents, when you place the plant material in between the electric field, the charging process is increased, the transmembrane potential, and lead into the breakdown of proteins and lipid bilayer of the plant cell membrane. When the transmembrane potential is exceed the range that cells can withstand, the cell's membrane is ruptured and pores are formed. Depending on the certain characters of the pulse electric field, the cell's membrane pore sizes and quantities are varies. So, these are the pulse electric field characters. They are electric field strength, pulse frequency, pulse number, pulse shape and polarity, specific energy input, pulse width, and duration. So my ambition is to explain the benefits and contributions of PEF application to the quality of plant-based frying product. The PEF treatment for the plant-based product are done before the cutting step. So any material is treated with PEF application, so additional heating step is not required and the energy consumption can be saved. The PEF treatment is modify the texture and structure of plant material and it facilitates to the processing and cutting process. Frying process of plant material. Frying is one of the unit operation where heat, mass and momentum transferring process are accompanied with the chemical and physical changes of the food material. Goal of frying process is produce a product with crispy texture, aromatic flavor and golden brown color. So many kinds of plants are used to produce the frying product. Potatoes, sweet potatoes, carrots, celery, red beet, apple, banana, peach, grapes, pumpkin, squash, tomato, green bean, eggplant and guava can be considered. Frying is a complex process where heat is transferred to the food material through the oil and which lead to the mass transferred by the water evaporations or by the oil uptake process. The heat transferring process is mainly occurred through the conduction and convection process. Heat transferring process. So in this process, this is oil, food material, convection process and conduction process. They are the two important processes you have to understand. So within the frying system, it has high heat transfer coefficient. The heat transferred from hot oil to the food material is occurred through the convection process. And the heat from surface to the inner part is done by conduction process. When the food material obtained the heat from the oil by convection process, it started to evaporate water from the surface of the plant material. This rapid evaporation creates an oil turbulence around the food material. This oil turbulence enhances the heat transferring rate to its maximum level. So large number of water bubbles cannot escape from the food material and they form an insulating layer on the surface limiting the heat transfer. This process causes the wasting of energy inside the food material and thereby it leads to the decreased available energy for the temperature increase. The following equation represents the energy balance during the primes, where KFF effective thermal conductivity, delta H latent heat sublimations and W for the water content. The pulse electric field treated plant tissues show more porous structure than the untreated one. With increasing porosity and electroporation, it also increases the moisture transferring rate. So when the moisture evaporation rate is increased, the heat transfer coefficient is also increased. So next is mass transferring process. In the prime process, mass transfer is refers to the water evaporation and oil uptake by the food materials. Pulse electric field treated plant tissue show high mass transferring rate due to its high porosity. Pulse electric field treated plant tissue show high diffusion rate of intracellular liquid to the outside is due to the electroporation effect on cell membrane. Plant tissue show faster prime efficiency due to the high diffusion rate. Mass transferring processes consist of two parts, oil transferring and water transferring. Water transferring process. This process is consists of four stages. First is initial heating stage, where food material drop into the oil and heat up until it reach to the boiling point of water. So the next stage is surface boiling period, where water begins to evaporate from the surface and rapidly water is lost as water bubbles. So in this stage, the crust is formed. The third stage is boiling rate stage, where humid core region is also heated until it reaches to the boiling point of water and the crust is also thickens. Fourth stage is bubble endpoint stage, where water evaporates slowly until bubbles are no longer released on the surface. Okay, now let's see the principle behind the water transferring process. During the prime, plant material is transformed into the porous medium consisting of tiny void spaces that are interconnected and filled with fluid. So the movement of water is no longer simple diffusion. Plant material contains high water content, that is high pressure is built up due to the operations of internal water during frying. The resistance of the porous structure is proportional to the thickness of fried foods. So this relationship is represented by the dark law, where QW is equal to the AK delta P divided by mu L. QW represents flow rate of water, A cross-section area of the fried food, K permeability of the crust layer, delta P represents pressure difference, mu represents viscosity of the water vapor, and the L for thickness of the fried food. So now let's see another mass transferring process. It is oil transferring process. This process is consists of three parts. They are water replacement mechanism, capillary penetrations, and mechanism of cooling phase effect. So first let's see what is water replacement mechanism. Where oil enters to the plant tissues through void created by the water evaporation. So water loss is basis of oil uptake. When the water bubbles escape by the tissue form capillary pathway and increase the surface porosity. So the next mechanism is capillary penetration, where oil accumulated in the void surfaces left by the water evaporation and move upward through the narrow pores in the filled materials when the adhesive forces between the oil and the food materials are stronger than the cohesive intermolecular forces in the oil. So this process can be described by the Washburn equation, where Q oil represents volumetric flow of laminar oil, Y represents oil circumference to the diameter, R for radius, mu for oil viscosity. And the third part is mechanism of cooling phase effect. This process explains the oil uptake of the food material after the remove from the oil. During the cooling period, water vapor condensation and reductions of the pressure can be seen. Oil uptake at this stage is balanced by the oil drainage and oil adhesion. Adherence of oil to the food surface due to the vacuum effect condensations of steam during the cooling period. This film formation and its thickness can be calculated using Landau-Rich-Derjguin equations, where H is equal to the oil viscosity, gamma represents surface tension, U represents speeds of oil removal, G accelerated gravity, and rho for oil density. Momentum transfer. So in the momentum transferring process is involved in the between molecules or group of molecules where vapor leaving tight materials by conventions of molecule forces like vapor or by pressure. Simply say it is represent a relationship between the fundamental variables of mass, velocity and time changes in the velocity per unit mass. The following balance equation used in the calculation momentum transfer. So, let's see the changes in chemical compositions of plant material during frying and effect of pulse electrical field applications. The plant foods are good source of carbohydrates and protein. Fryings of plant foods at high temperature initiate series of complex reactions and these cause to affect the general compositions of plant tissues. So, they affect on the quality, flavor, color and smell of the final product. Maillard reaction. Maillard reaction. This is one of the most important reactions in the frying process, since it contributes to the color and flavor of the final product. Primarily, Maillard reaction is occurred between the amine group of the protein molecule and carbonyl group of the reducing sugar. The following sequence reaction shows how the Maillard reaction occurs and the way of color contribution to the final product. So melanidine is the final product of Maillard reaction and the alpha dicarbonyl compounds which are responsible for the brown color of fried food. Temperature, pH, time, reactant type and concentration, water activity are the main factors influence the Maillard reaction. Reducing sugars and amino acids accumulated in plant tissue vacuoles and they are leached out to the cell electroporation as PEF treatment as applied. This process is benefit for the plant material which contain high sugar content because excessive amount of reactant can be eliminated and control the reaction rate of Maillard reaction and caramelization process. So next important chemical reaction is starch-gelatin and gelatinization. For example, potato tubers are high in starch content and it is considered as semi-crystalline biopolymer. During the cooking process, starchy food absorb water and sweat. Then the starch granules are open and amylose and amylopectin leach out. Water molecule forms hydrogen bond in between these polymers and form a lattice structure. So the solution becomes translucent and gelatinized. So simply say the starch molecule collapses its molecular structure and leaching to the irreversible changes occur as a result of water uptake and cause to solubilizations of starch and increase the viscosity of the medium. During the frying process, starch swell begins at 60 to 70 Celsius and the process is finished only after the swollen starch granule completely occupy the interior of the cell which acts as barrier to the oil penetration. So this resistance is extended all over the frying process in the crust and core region and which cause to obtain the different rates of heat transfer and water availability. After the pulse electrical field treatment, suggesting that plant tissues are more susceptible to the gelatinization. Because under the influence of pulse electrical field treatment, the crystalline structure, region and the side change of the amylopectin in the starch can be modified, leading to the decrease in double helix bonding force and disturb in the intragranular molecular arrangement of starch granule. So these changes reduce the energy barrier for the reaction between water molecule and the starch granule. Starch gelatinization temperature and the enthalpy of the gelatinization can be decreased with the temperature. Okay, now let's see the pulse electrical field treatment towards the quality of fried foods. Color, moisture content, oil uptake, texture, and the toxic compounds are the main quality parameters of fried foods. And first one is color. Color is important as the visual perceptions of the food material. Apart from the Maillard reaction, oil degradation is also affect the color changes, where polymerizations of triglycerides and product of triglycerides hydrolysis such as free fatty acid monoglycerides can be seen. Frying temperature, time, and the oil uptake of the food material are the other factors that are affect on the color contributions of the fried food materials. So the next point is moisture content. When the plant material placed in the boiling oil, the surface temperature is reached to the boiling point of water and surface water is evaporated. As you know the result of this process, the surface is first dried and the crust is formed. The evaporation process of water is caused by many other factors such as frying temperature, time, shape of the products and pre-frying procedures such as drying, pulse electrical field treatment prior to the cutting process. It also accelerates the moisture loss. So the pulse electrical field treatment can be used to increase the frying and drying efficiency of fried products. So the next point is oil uptake. As we discussed earlier, the oil uptake is happen as a result of water evaporation. Apart from this, there are many other factors also affect on the oil uptake. They are oil characteristic, frying temperature, time, food to oil ratio, food characters like size, roughness and porosity, treatment like blanching, edible coating and vacuum drying. So investigation revealed that pulse electric field treated potato shows lower oil uptake rate than the PEF untreated potatoes. So the quality of frying food can be increased using the PEF treatment as it decreases the oil uptake. This phenomenon can be explained as because the PEF application is caused to increase the porosity structure of the plant tissue and this leads to the higher vapor pressure and faster vapor movement to the surface, which limit the oil absorption. Pulse electrical field treated plant structure shows a smooth cut surface and they inhibit adherence of oil to the surfaces. Another most important process is that cell electroporation effect is caused to increase the formations of capillary and which result in increase the tendency of oil leach out. So the next is texture. The texture of fried food material is depending on three characters. They are porosity, crispiness and shrinkage. Some water vapors cannot evaporate during frying as a result of restrictive intracellular diffusion. Intense water evaporation leads to the formations of more porous structure. High oil temperatures and hydrogenated oil cause the porosity. PEF treatment also causes increased porosity as it leads to the enhanced heat and mass transfer which result in intense water evaporation. Crispiness. Crispiness describes a quick fracture under small strain stresses owing to the low water content in the surface layer. Crispiness is effect on the frying time and temperature, oil content, moisture content, starch content, porosity and the roughness of the surfaces. PEF treated food shows more crispiness than PEF untreated one. Starch show major contribution toward the texture and therefore excess starch loss should be minimized. Shrinkage. This is caused by the water loss and result in the results of reduction, open pores and increase the density of fried foods. During frying, the initial shrinkage is occur at the surface and it leads to the formation of rigid outer layers. Finally, shrinkage is move inward and final volume is fixed up. Shrinkage process is affected by the frying time and temperature, shape, size of the cuts and density. So the final quality parameter is toxic compounds. Toxic compounds that may produce during frying are acrylamide, hydroxymethylfurfural, furan, ethyl carbamate, heterocyclic amines, polycyclic aromatic hydrocarbons, nitrosoamides. The acrylamide is produced during the Maillard reaction, where carbonyl group of reducing sugar are react with asparagine at higher temperature like 120 Celsius. Factors like temperature, pH, time, and the material characters like water activity, chemical constituent, and the cultivar are effective on the rate of acrylamide formation. PEF directly affect on toxic formation rate. As it decreases the reactant content, the amount of toxic compound formation is also decreased.